in this example, we're looking at a group of data, and let's read what this data represents here. A professor at a large community college wanted to determine whether there is a difference in the means of final exam scores between students who were allowed to text in class and those who weren't. She believed that the mean of the final exam scores for the texting class would be lower than that of the non-texting class, but her students didn't think so. Were the students correct? Well, in this case, we've got some data to help us answer the question. So the professor randomly selected 30 final exam scores from each group. Here we've got the data from the texting class. In other words, this was the class where the students were allowed to text, and this is the class where students were not allowed to text. And what will help here is that we can use the data to input into our calculator function to help us compute the p-value and test statistic for this data. So before I continue to the next slide, what I want to do is enter all the data here into a list. So here we'll enter this data into one of our lists, let's say L1, and we'll enter this data into another list, say L2. Okay, so we'll take a moment to enter all this data into two separate lists, and then we'll use those lists in our 2SAMP t-test to compute the values for us. So before we get to the next slide, I'm going to go ahead and enter these values, and then we'll get all the data that we need. Now that we've got all the data input into two lists, let's continue with the rest of the problem. Now first, of course, we're always going to state our null hypothesis and alternative hypothesis. So for H0 and for H1, we'll have the mean between the two classes is the same for the null hypothesis. And for the alternative, we'll look at the claim that the class that had no texting had a higher mean. Okay, so here we'll have mu1 be the mean score of the texting group, and mu2 is the mean score of the non-texting group. Okay. So with that set up, now we're basically ready to punch it all into 2SAMP t-test. Right? Because we've taken the moment. It may take you a little bit of work to enter all that data into the lists, but once it's all entered, then all we do is we can reference each of those lists. So make sure for input, now we're going to use data, and we can reference each of those lists. In my case, I entered the data from the first group into L1. So for list 1, we'll reference L1, and for list 2, the second list, I used L2. For the frequency, we'll just use 1 for each. And then mu1 is less than mu2 is the alternative hypothesis that we're using here. And then we're basically ready to hit calculate. And then of course pooled will always be no. So the test statistic that we get is the t-score -3.228. It also gives us some other information, but let's look at the next slide and we'll make our conclusion. So with a test statistic of negative 3.228, so that would be pretty much in this territory over here. So it's going to have a very small p-value there. And in fact, that's what we observe here, is that the p-value that we get is about 0.001. And that's certainly less than the default significance level. We got a value of 0.001, certainly less than default value of 0.05. So here this kind of gives us an obvious conclusion that we're going to reject the null hypothesis now. And so what does that tell us now? Well, the conclusion that we can draw is that because the alternative hypothesis was that mu1 is less than mu2, and we were able to reject the null hypothesis, well then we essentially have enough evidence to support the claim that the non-texting class had a better overall average than the class that was allowed to text. So there's evidence to support the claim that mu1 is less than mu2. So the non-texting class had a better overall average than the texting class. So one conclusion we can make here is that here allowing students to text did make a difference in their performance. So in this case, it may have a negative impact on their performance.